Alright guys, welcome to the Tic-Tac-Toe game made in Pygame. So the previous parts we created the icon, and actually we can already play the game. So every time I place an icon, the AI plays another one in a random location. In this case it's all randomized. We don't have the winning function yet, so it's not checking if someone won or not, but we have managed to play the game and place all the icons. So the next thing we're gonna do is actually that winning function. So we're gonna check if someone win or not. Right under the update function here, we're gonna define a function called isWinner, and inside of here as a parameter we're gonna take the boards and an icon. Okay, I guess you could pass in these boards straight away in there. I'm just gonna use in here. It's gonna be a bit shorter to call board instead of calling self.boards.boards list every time. Okay, so whenever we call this function, I think we're gonna be calling this if statement here. We just pass in that boards in there. So in here we're gonna have a few checks. So we need to check for horizontal winning. We need to check for vertical winning, and also we need to check ascending diagonal, and then descending diagonal. Okay, ascending, yeah, that's correct. Ascending diagonal and descending diagonal. Okay, so we need to check horizontal, so those three here, three there, or three there. Vertical, three there, three there, three there. Or we have ascending diagonal and descending diagonal. Okay, so let's do all those checks. They're gonna be pretty much hard coded in there. So for the horizontal, for example, we're gonna do just a simple for loop in range of 3, because we have 3 columns in there. And then if the boards row and 0, because we are checking each column, we're only checking the first one for now. We're checking each of the columns, yeah, and then we're gonna be looping through the rows. If that is equals to an icon, and boards row 1 equals to an icon, and boards row 2 equals to an icon. Okay, so you see we're going through the first row, so that's 0. We're checking the column 0, 1 and 2 to see if they are the same. If it is, then someone won, the icon won basically. And then we go to the next row, which is 1. We check that row 1, 0, 1, 2, and then the row 2, 0, 1, 2. Okay, if any of this returns true, then we're going to literally return true. Okay, and then later on we're going to be drawing the lines in here as well once we have those lines. Okay, let's check vertical. What we're going to do in here, I'm just going to copy, paste that in here to the vertical. Instead of row, just change that to column. All of this to actually no, this is gonna be the inverse, so it's gonna be 0 and then column, and then the same here, 1 and then column, and then here is gonna be 2 and then column. Okay, now we're checking all the vertical lines and we return true if any of them it's all the same. Now for ascending, that's also very easy. We don't need to do a for loop in there. We will literally just check for boards 2, 0 equals icon, and boards 1, 1 equals icon, and last one, boards 0, 2 equals icon, and then that returns true. Okay, so again This one ascending, we're checking for the index 2 and 0, which is this one here, and then 1 and 1, which is the middle, and then 0, which is the first line, and 2, which is this one here. Now we do the same thing for the descending. We're just gonna copy this and paste it down here because I'm lazy. First one here, we'll check the top left is 0 0, the middle still 1 1, and then the bottom right is 2 2. Okay, this should be done with the winner function. Let's just call this function in here. Okay, so if it's not the player turn and is not full and self dot is winner, we're passing the boards list, and we're gonna pass in X in here. We're gonna check if the X is winning or not. Okay, so the player. So if the X didn't win, then we can play with the AI. Okay, so now I believe I can win. What happened? Why is it not placing? Oh, this needs to be not self-thought is winner. Okay, now I believe I can win. So the AI didn't play anymore. I can't play, I can't do anything else. Okay, I'm gonna do it again. Here. Once I play this one, the AI is not placing anymore because I already won. Okay. Now let's actually draw the lines. So we're gonna be drawing those lines. Whenever I win, you will draw that line vertically or horizontal or diagonal whenever you win. Again, I'm just gonna try to go very quickly on this because there are just math involved to position. We're gonna be drawing lines the same way that we draw the board. And then we just have to figure out where do we start the point, where do we end, so we can draw the line in the center. And then we're gonna separate them into different functions for horizontal, vertical, and diagonal lines. And then we'll just call them inside of here, depending on which line we need to use. Oh, actually, so in the winner function, we're gonna be doing this just under this function here. At the ending here, I forgot something. We have to actually return false in here, okay? Because if we don't return true for any of this, then we just return false at the end. So we can check this in here, okay? And let's just define this function. So define draw horizontal line. And the only thing we need to take in here is the rows and the columns to where we're drawing the lines. So to draw the horizontal line, we're gonna create a variable called pos_y, which is equals to row times tile size plus margin y plus tile size divided by 2. Okay, so again, just a little bit of math that I had to calculate just to put those lines in the correct position. And then that's gonna be the position y of our line basically. So pygame.draw.line self.screen. We're gonna draw that as light gray actually. And then, as I mentioned before, the line has two tuples. One x and y coordinate of one point, the second x and y coordinate of the second point, and it draws a line between those 2 points. First one is margin x plus tile size divided by 2 and with the position y. The second is margin x plus 5 times tile size divided by 2 and position y. And then in here again, I'm just gonna put 3 as the thickness. You can put more if you wanted to, either 3 or 4. And I'm just gonna copy this and paste for the vertical lines as well. So copy the whole function, paste it in there. I'm just gonna change this to be vertical line and change this for column. Okay, so the position y variable, again, we're just gonna change this for column times style size plus margin x in this case plus style size divided by 2. And then in here we draw the line, this green, light gray, and then in here is going to be position. This variable here, I'm going to change that to position x because now it's the position x basically. This one here is going to be position x for the first argument, and the second argument is margin y plus style size divided by 2. So we don't need that position x, position y in there. So we're just inverting them basically. You see here I have margin x plus 5 tile size divided by 2. We're just going to invert those two, and we're going to become, this is going to become the x, and then the other one is going to become the y. So I'm just going to put in here position x, comma, then instead of margin y is instead of margin x is margin y plus 5 times style size divided by 2, and we don't need this one here. Okay, easy. Now we're gonna do the same for define draw ascending diagonal, and we don't need to take anything in here because we're just gonna be drawing those lines there. Again, pygame.draw line self.screen light gray, and whoops, light gray, and then we have two tuples in here. The first one here is margin x plus tile size divided by 2, comma, for the y x coordinates, and then margin y plus tile size divided by 2. Second tuple, margin x plus 5 times tile size divided by 2, comma, margin y plus tile size divided by 2, and then comma 4 for the width. Okay, so this one here is margin y plus 5 times tile size, so it's the same as this one basically, divided by 2, but this one is x, this one is y, and I think that's it. I'm just gonna copy this and paste it down here. Instead of ascending, it's going to be descending. You write that wrong. Descending like that. And then this is gonna be just slightly different. So margin x plus tile size divided by 2, margin y plus tile size divided by 2. So in this case here is plus 5 times tile size divided by 2. And the second one is margin x plus 5 tile size divided by 2. Margin y, we don't have this 5 in here. Okay, I think that's it. So we're gonna test in a bit to see if everything works correctly. And again guys, I know this is a bit much, but these are just numbers and a bit of math that I had to try and test it. Like this 5 in here, I just have to test which number is best in there to get those lines correctly. So what we're gonna do in here to test everything is go to the update function, no, go to the draw function. Okay, so down here to the draw. After we draw the icons, I'm just gonna call those functions one by one just to make sure they are correct. So draw horizontal line, I need to pass a row, let's pass in 0, and then we have that on the top there. Okay, let's try 1, yeah, in the middle, and then 2 at the bottom there. Okay, let's try the draw vertical line, run that, in there, that's good. Let's try with 1, in the center, and then 0 at the beginning here. That's fine. Let's try ascending. Draw that. Okay, ascending, that should have been this one. Did I make a mistake in there? Let's draw descending. Oh, okay, I just inverted them. Okay, it should be all good. Just to fix this, come back in here to the draw functions. You're just gonna do descending for this one, and then ascending for this one. I just inverted them. So the next thing we're gonna do in here is, the game is kind of playable already. So if I try to win over here, okay, well, I'm not drawing the lines. Let's call those functions actually in here. So whenever we win on a horizontal, we call horizontal line. If we win, always before the return, yeah? We need to pass in the row in here. If we win on the vertical, we call the vertical one. We pass the column. This is ascending, and then this is descending. Okay, let's just test this out. If I win in here, I still didn't draw. Let me check, why is it not drawing? Yeah, of course, it's because we need to do the checks at the end. So in the draw function, because we need to be calling this isWinner in the draw function to be able to draw those lines basically. And this draw function, we're just gonna do a if statement in here. So we're gonna have a few statements in here. We're gonna check if isWinner self.boards list x, should be capital X, whoops, like that. So if the player X wins, we're gonna do self.playing equals false, and then this is player 1. We're gonna add some more stuff in here in a bit, but this is just so we can test it right now. If isWinner self.boards list O, that's the computer winning, so computer 1. We still do self.playing equals false, and that's it for now. And then the last thing in here is elif self.boards is board full. Again, we do self.playing equals false. This means is a tie game. Okay. Okay, let's see if this is at least drawing the lines for now. Okay, yeah, it's drawing the lines in there. It's just because I have this line in here. Let's just test like this for now. So if I the computer one, if I win here, okay, it draws that one there. Let's try one more time like this. Okay, it draws that line in there, so it should be working. So the next thing we're gonna do now is we need to create those scores and then also the end screen, and then at the end we're gonna create the smart AI. Let's go into the sprites. We're gonna create another class in here called the UI element, which will be showing all the UI. So go at the end here, class UI element, and we define a constructor. Again, we just take an x and y and a text, and self.x self.y equals x and y. Oh no, x and y. Self.text equals text, and then we just define the draw function here to take a screen. I'm gonna take a font size in here as well, because I think we're gonna be changing the font size between the elements. Again, we're just gonna create a font in here. So pygame.font .sysfont consolas font size take text is equals to fonts.render self.text true and white, and then we do screen.split text and then self.x self.y. Very simple, this UI class here. That's it for the sprites actually. Now go back to the main file and let's create some variables here at the top. So go at the top of your file and we're going to create this self.player score equals to 0, and then also computer score equals to 0. So we're gonna create this on the constructor, not on the new function, because every time we initialize, we click to play again, we want to keep that score. And then let's say we want to play 10 times and see if I win more than the computer or not. If you put this in the new function, then you reset that score every time. It's a bit pointless basically. Now we're just gonna add those variables in here. So go back into the draw function where we were checking who is winning and if it's a tie. And whenever the player wins, we're going to do self.score player score plus equals 1, and we're also gonna create a UI element at 160 500 saying you win. Dot draw self.screen and then with font size of 40. So this is the text that will appear if the player win. Okay, and then we just command Control D just to duplicate that. We're gonna have another text in here at 100 and then 550 saying click anywhere to play again. And then this is gonna be slightly smaller, this font size. Okay, so just copy those two lines and paste it in the computer one section. So if the computer win, then we're gonna say you lost, sad face. We're just gonna change these coordinates in here a little bit. Should be 140 and then 500, and then the second one should be the same. So guys, this is this coordinates here I was just testing, so I'm just hard coding them. I was just testing on the game to see where was the best position to put them. And then the last one in here, we just gonna paste that again in here, and instead of saying you win, this is going to be it's tie. Okay, and then we're gonna change this again to 140 and then 500. The second line should be the same and should be all the same in here. And then outside of all of these if statements, we're just gonna create another two UI elements for this course. So the first one is going to be at 50 and then at 40. The second one is going to be at 350 and then at 40. And then the text in here is going to be a f string saying you, and then we pass in your self.player score, and then here it's going to be AI, and we pass in self.computer score. In the computer winning here, we actually need to increase the score of the computer as well, the same way we did for the player. So computer score plus equals 1. Okay, so just don't forget that. And at the end here we just flip. Okay, so this should be all the draw function. Okay, so if you miss something there, just give it a pause in the video here, just make sure you have everything correct in here, all the values. Okay, let's just give this a quick test. Okay, the AI, I need to just change the font size here. It should be 30 and then 30. Run this again. Okay, now it's good. Computer started. I'm gonna try to win here. Okay, so I won there. It updated the score. Let's try again. Okay, yeah, let's see if the AI can win. Yeah, the AI won like that. It's not stopping yet because we don't have an end screen to hold everything. We're gonna create that next. But yeah, it's working for now. The scores are updating and all of that. Now let's go down here. Just after the events function, we are going to define a function called end screen. And basically in here I'm just gonna copy this. So basically in here we're going to create a while true. Basically it's gonna hold us to the end screen until we click on the mouse button. So while true, and then I'm gonna copy this events in here all the way down to mouse button here. Okay, so copy that, paste that in here. So we have the events to check whether we quit the game, or if we click the mouse button we just return. Okay, so we get out, we return this function here, we get out of the while true, and then we start a new game. Okay, so that's what we should be seeing. Not yet, because we're not calling this function here. So we're gonna do that all the way up here on the run function, because we are, every time someone wins or is a tie, we are setting the self-stop playing to false. Okay, so while self-stop playing, if this is true, we do this. And I don't know if you guys knew, but you can add else statements to for loops and while loops. So if this is not true anymore, we execute the else. So then we just call our end screen. Okay, so let's try to win like this. Okay, there we go. Win like that. It says you win. Click anywhere to play again. And then if I click on it, update the square, all of that. And then let's try again. Okay, I won. Update the square. And then we can always play. Again, let's see if the computer can win. There we go. Computer won there. You lost. Click anywhere to play again. Alright, that was a very long journey. I think the last thing we need to do in here is just to create a smart AI, and then we're gonna be done. Okay, so I'm just gonna power through this part and just end up this video with the smart AI. Okay, to create the smart AI, we're going to go down here after all these draw functions, after all of this. So we have the dump AI in here. Just after that, let's define a function called, I guess, smart AI then. If we called it dump AI before, I'm gonna call it smart AI now. Okay, so what this smart AI do is just, it has a list of possible movements, and then it picks the best movement from that list. So it's gonna check our moves. If we are about to win on the next round, then the smart AI is going to prevent that win. Or if the smart AI knows it can win on this move, it will just place that winning move and it will win the game. To start this, we need to first create a list of possible moves. We need to go through this board's list, and then we need to take all the coordinates of the possible moves, so the ones that is an empty string. Okay, hope that makes sense. And to do that, we're just gonna do so there's two ways of doing it. Okay, you can create a possible moves. I'm gonna have that anyway. You can create a possible moves empty list and do a nested for loop, and you can enumerate in range of this boards, same as we done it here. So you could do something like this, and then you check whether the icon is empty, and if it is, you just append a tuple of I and j to this list here. Okay, so you can do like that. And then another way of doing inline is what I'm about to show you now. So inside of this list, we're going to have a tuple, which is a coordinates I and j for I and row, and enumerate self.boards list for j and icon in enumerate row if the icon is equals to an empty string. Okay, so just going back, we are gonna add this coordinate I and j for I and row in enumerate this, and then for j and icon in enumerate the row only if the icon is an empty list. Okay, and then we're gonna have this coordinates of this, the empty list icons, the empty string, sorry, not empty list. And then here we're gonna have a bunch of if statements in there to do some checks. So the first one is for icon in O or X. So we're gonna loop through the O's and the X in the possible moves, okay? And then for move and possible moves. And we're going to do X, Y equals move 0 and move 1. So we're just taking that move variable, the X and Y coordinates, and storing into this X and Y coordinates just to be a bit easier. And then we need to do a copy. So we're gonna create this variable called board copy. We're gonna do copy dot deep copy, okay, self.boards list. So we're gonna make a copy of this boards list so we don't mess up with the original, because we need to test. So we need to add a O to the first slot of the boards and see if we win. If not, we add the second one. Did we win? No. And then check the second one, the third one. Did we win? No. And then you just add an O to all of them. Check if it's a winning move. If it is, then we play that. And then you check for the X. You add the X into all of the possible moves. If any of those is a winning move, then we means that the player is gonna win, so the AI can place an O in that position. And then we're gonna do boards.copy xy equals to the icon, and then here we do the check. So if is winner board copy, we're gonna use that board copy and icon, then we return X and Y. Okay, so we're gonna go for the O's first, check all the possible moves. If any of them is a board winner for the computer, return that coordinates and place that icon so the computer wins. Then if we don't get a winner with the computer, we check for all the X's. If any of those is a winner for the X, for the player, then returns that, so the computer places the O in that space and doesn't let the player win. So that is the first part of this smart AR. Now the second part is we're going to create a variable here called open corners, which is a list. And again, we're going to do for move and possible moves, and if the move in 0 0 or 0 2 or 2 0 or 2 2, then we do open corners, open why is it not? Oh, I forgot the equal sign here. Open corners dot append move. So what this is doing is, if we go through all of this and none of them are winning moves, then we're just starting the game basically. Then the first thing we're gonna do with the AI is to place a move into one of the corners. So we're gonna take the open corner and we're gonna go for move in possible moves. If any of these moves is one of the corners, we just add all of those corners to this list. Okay, so we're creating a list of all the open corners. And then if the length of this open corners list is greater than 0, that means there is at least one open corner. We do move equals to a random.choice. Okay, so we're just gonna pick a choice, a random corner, and then we're going to return that move. Okay, so then we return move 0 first, 0, comma, move 1. Okay, so if we don't win, if the computer can't win or the player can't win, then we're just gonna choose one of the corners. If there's no corners available, then let's place the computer right in the center. Okay, so if 1 1 in possible moves, then just return 1 1, which is the actual center. So if we can't place in the corners are already placed, then we check for the center. If the center is not available, then we're going to check for the edges. So all the open edges. And what we're gonna do here, we're gonna copy these open corners here because it's gonna be very similar. Paste it into the open edges. So for move in possible moves, and if the move is, so the first one is 0 1, the second one is 1 0, the third one is 1 2, the last one is 2 1. So these are the edges, not the corners, and not the center. Okay, if any of these available, we append to the open edges. And then if the length of the open edges is greater than 0, we pick a random edge and we return that move. Okay, brilliant. That is all for this smart AI. So if none of this returns anything, that means it's a tie. So because we're checking for all the corners, for the center, and then for all the edges. Okay, I hope this code is making sense for you guys. I just want to point out that this smart AI code, it's definitely not my code. I did not come up with this. I believe I took from Tech with Tim. I took his code because he has like a tic-tac-toe. I think he has a text-based version. So I believe I took this smart AI code from him, and I just made a few adjustments in here to work with our code. Okay, so yeah, I don't want to take any credit for this smart AI, or it's not really a AI. If you can sell it, we're just checking for all the possible moves that we can do, because the board is very small, so we can do that. We can check for all the possible moves. You wouldn't be able to do this on checkers, for example, or on chess, because there's just millions of possible moves, I would say, right? Okay, so the very last thing we need to do is just to actually call this function. So right now in the update function here, we're calling the dumb AI. Instead of that, let's just call the smart AI, and let's try this out. Okay, I'm gonna start, I'm gonna place in there. Okay, so the computer placed on a corner, so you see there's no winning move for O or X, and then we check the corners first. So the AI placed in one of the random corners that are available. I'm gonna put in here, you see the AI placed in there, because now there's a winning move. Now if I don't place it in here, the AI will definitely win there. There we go, you see, because it's a winning move. Let's try again. Place in the corner, so the AI placed in one of the corners. I'm going to go here, so the AI places in there. Now I'm going to place in here. Once I place in here, the AI is going to have two choices. So either here is a winning move for me, or either here is a winning move for me. As we're going like this, so we check this, or this, and this, the AI is gonna place the winning move in here, or to cancel my winning move. So when I do this, the AI places the O in there and leaves this one blank for me to win. Okay, let's try in the middle here. The AI can't win there. There's nothing really I can do. If I put it in here, the AI puts it in there, so it doesn't let me win. And I'm not gonna let the AI win here. There we go, it's a tie. Alright, I think that's gonna be it for this tutorial. I hope you guys enjoy it. I hope you guys understand this code. And if you have any questions, just drop me a comments down below and I'll make sure I'll read it and answer back to you. The full code for this tutorial is going to be available on my GitHub. I will just post the link down in the description. And okay, yeah, I'll see you guys on the next tutorial. Stay safe, guys. Bye bye.